This section is about increasing and decreasing functions. The first thing we want to realize is what is the true definition of increasing. If we're looking at an increasing function, we're looking as we go from left to right, when is a function going up? Decreasing means as you go from left to right, when is the function going down? And a constant is when there would be no change in your y value. So, when we determine intervals of increasing and decreasing, what we're also looking at is the slope of the graph. A function is increasing if its slope is positive. A function is decreasing when its slope is negative. Well, as this is a calculus course, we know slope is directly related to the derivative of a graph. The slope is the derivative. So when we said a function is increasing when its slope is positive, what we're really saying is a function is increasing when f prime of x is positive. And a function is decreasing when the derivative f prime of x is less than 0 or negative. Yes. Likewise, we could go the other direction. If the derivative is positive, that means the function is increasing. And if the derivative is negative, that means the function is decreasing. So, if a function is differentiable on an interval, and its derivative is positive in that interval, then we know it's increasing in that interval. If the derivative is negative in that interval, we know it's decreasing in that interval. And if the derivative is equal to 0, we know that it's constant. The rest of this section will be looking at how do we determine when a derivative is positive, how do we determine when it's negative, and how do we determine when the derivative is 0, because that'll answer the big question of when is my function increasing, when is it decreasing, and when is it constant. So now we want to look at when is a function decreasing on an interval, or how is it increasing on an interval. To do that, to determine when a function is decreasing and when a function is increasing, what we really want to do is consider the derivative f prime of x. Using the simple power rule, we know that the derivative of x to the fourth is 4x cubed. So consider that on the interval negative infinity to 0, and then separately on the interval 0 to infinity. Consider the first interval, negative infinity to 0. All of your x values are negative, so when you think about it and you look at 4x cubed, when you plug in any negative number in there, the whole entire thing would be negative. That means on the interval negative infinity to 0, the derivative is negative. And then we know if the derivative is negative, the function is decreasing, which I have now written out. Consider on the interval 0 to infinity. Again, we're looking at 4, plug in any number from 0 to infinity, cubed. When you plug in a positive number cubed is positive, times 4 would still be positive. So what we've said is on the interval 0 to infinity, this function, the derivative of the function, must be positive. Again, if the derivative of the function is positive, then we know the function is increasing. Looking at the next example, they want to show that something was increasing on a given domain. So all we have to do for that one, find the derivative of the function, consider it on the interval, which this interval would be 7 to 12, and show that the derivative must be positive during that interval, which can be shown in the completed notes. So how do we determine when a function is increasing and when a function is decreasing? Again, we said a function is increasing when its derivative is positive. A function is decreasing when its derivative is negative. But consider a point where it changes from increasing to decreasing or from decreasing to increasing. That point right there is a very special point. The value at that point can't be positive, can't be negative. It either has to be a derivative of 0, or it has to be a point where it's undefined in a cusp like this. So we're interested in finding the points of where a function changes from increasing to decreasing, likewise when a function's derivative is changing from positive to negative or negative to positive. This is such an important concept that we give these points a special name called critical numbers. So a critical number is the value c, an x value, where the derivative is equal to 0 or where the derivative is undefined. What's really important to note about this one is that the original function must be defined at that point for it to be a critical number. So make sure it's in the domain of the original function. How are we going to find these critical numbers? First thing you're going to do is set the derivative equal to 0 and or when it's undefined and solve the equation.